talk about this week, and then we'll get cooking on today. So, normal blended weeks, we have lecture live Monday and Tuesday and Wednesday. Okay? So for you remote folks, Tuesday, that's why you're here live. Tomorrow, I expect remote folks to also be coming to class live. This Thursday, okay, you in-person folks, Cohort B, you're going to do the Flame Test Lab Part 2. It's been over a month since you did Part 1. You might not even been here for Part 1, yeah?
I wasn't here, so
Yeah. We're going to get that worked out. I know some of you guys weren't here. I know some of you guys are like, I don't know where that handout is. It's been a month. I don't know what color flames burn. It's going to be a very low stress situation, okay? It's an opportunity for you guys to get some hands-on experience in the lab. And I'm not going to have it be the same as it was for Cohort A, who got to do it like back-to-back days. Does that make sense? So don't get too stressed about it. It'll be fun. Thursday will be fun. Cohort A people, Thursday you do not need to come see me. That is a lab day for in-person folks. You guys have a study day that day. You'll be doing lab next week, of course. This Friday is the Unit 5 test with a T, test. So everything that we learned since winter break ended, so that's 2 weeks ago, last week, and this week, are fair game for this Friday. Does that make sense? Okay? So that's what's coming up this Friday. Today, I'm going to do a little bit of lightning review. So the first 15 minutes, nothing new. Okay, I'm just going to be bugging you guys about, oh, what is this group called? What do they do? What about this trend? What about reactivity over here? That kind of thing. We're going to go over the 3 most missed questions from last week's quiz as a class. Okay. And then at the end of the period, you guys are going to have your normal 3 questions after lecture. Okay. These 3 questions will they will mirror the 3 most missed questions from last week's quiz. And I'll talk a little bit more about that here in a minute. But that's where we're going. Okay? So we're going to start off with a little bit of lightning review. I'm just going to be bugging people. Today is one of those days, so if I'm like, all right, Billy. You guys are looking for a Billy. There is no Billy. I'm like, Billy, what's this group called? And you don't know. Just be like, I'm not really sure. Here's my best guess. I don't really know for sure. That's okay. Today is an all right day to not be sure. Friday is a bad day to not be sure. Does that make sense? So that's why we're practicing. That's what we're doing here. So don't get too salty. If I call you, you don't know what's going on. We're practicing. But this should be mostly review. All right. So first person, let's see here. I'm going to go with Meg. Meg, are you with us? Hello. Meg, I would just love for you to pick a group or 2 off the periodic table, whichever ones are your favorite. Tell me where they are and what they're called.
Okay. I gotta go with my first favorite. The natural gases.
Okay, where are they?
That is group 8.
Mm-hmm. So group 8
is on the line.
Yep. All the way over here. Noble gases. Okay, the noble gases. What can you tell me about them, Meg? Do you know any characteristics about the noble gases?
They don't react with anything.
That's right. They don't react at all, or one word we might use for that is inert. They don't react at all, okay? So they're really safe gases in that sense because they won't react with anything. All right. Hey, Meg, give me one more group or one more section somewhere on the periodic table.
Okay. There's the transition metals, which is the big part in the middle.
You got it. Boom. Transition metals as you transition from metals to non-metals. Love it, Meg. Great. Let me see here. Adam, give me something else. Anything else you want off the periodic table?
alkali metals.
Okay, where are those?
On the very left.
Yep. Group 1. What do we know about alkali metals? What's the characteristic of them?
They're reactive.
They're super reactive. Yep, you got it. Love it. Somebody give me something else. Is that you, Lexi? Does it say? Okay, where are the rare earth metals? Where are those?
The bottom part.
The bottom part. Yeah, the big block down here. These are called the rare earth metals. Nicely done. Who's got something else for me? Yep, Tanner?
Group 7 is a halogen.
Yep, you got it. Do we know anything about the halogens? Are there any common characteristics?
Very reactive with gases?
Non-metals. Most of them are gases, but they're all non-metal. Yep. So alkali metals are really reactive metals. Halogens are really reactive non-metals. Okay? Anything else on here? Can anyone give me anything else? Lexi?
Metalloids.
Where are those?
They're the last section. Right
We're here. Where are we? Left, right?
we're like next to the halogens.
Okay, yep. So remember there's a stair step where there's a handful of elements that are called metalloids. They're kind of half metals, half non-metals. So silicon, element number 14, that's an example of that. Where it has some characteristics like a metal, it also has some characteristics like a non-metal. Does that make sense? You can actually make a boatload of cash dedicating your career to the metalloids because they're really versatile and you can use them in all kinds of stuff. So silicon can be used in plastic surgery, and it's also a main component of computers. So it's like really versatile. And what's the one thing we're missing here? Yeah, Mary? Woo! Look at you, alkaline earth metals. Nice pronunciation. Pretty good. They're group 2. Group 2. Not bad, not bad. Make sure you pay careful attention to which ones are reactive and which ones are not reactive. So halogens, alkaline metals, super reactive. Noble gases, don't react at all. That's helpful for your trends coming up here in a second. All right, trends. I'll talk about some of these myself. So metals, now you don't have to draw this, but metals, which are generally everything to the left of that red line right there where the metalloids are, they tend to give electrons away, which makes them a positive ion, also known as a cation ion. Remember that? I use the plus sign as a T, right? Cats have paws, too, right? You guys, oh, what's up? Really good joke, Mr. Pelcher! And nonmetals to the right of this line, generally speaking, they tend to take electrons, making them negative anions. You guys remember that. We also talked about atomic radius. This is a bigger one. As you go down a group, atoms get bigger, okay? So hydrogen, the top of the alkali metals, is the smallest alkali metal. Francium, the bottom, that is the biggest. Hey, what are we adding every time we go down a row in the periodic table? What's being added? Yeah?
Valence, electron, or orbital.
Not energy level. That's a nice save. Yep. Every time you go down, you're adding an energy level. So if you go from hydrogen to lithium, you went from 1 to 2 energy levels. Go to sodium, 3 energy levels. Potassium, 4 energy levels. So as you work your way down, you're adding energy levels, and that makes the atom get bigger and bigger and bigger. Okay? So as you go down a group, pretty straightforward, elements get bigger. Now, the part of the atomic radius that's a little confusing for folks is you go left to right. So take a look at magnesium and sodium for me, elements 11 and 12. Okay? They are both in period 3, and therefore they both have 3 energy levels. So in terms of which one's bigger, you're like, well, I'm not really sure. Again, this is sodium and magnesium. They're on the left-hand side, elements 11 and 12. So which one's bigger? Like, well, they both have 3 energy levels, so that doesn't really help me. Magnesium has 1 more proton, which makes it a teeny bit more positive in the center. And so that extra positive charge pulls this electrons just a little bit tighter, and it makes magnesium a little bit smaller than sodium. Okay? So elements will get smaller as you go that way on a periodic table. So magnesium is actually a teeny bit smaller than sodium. It also means that noble gases over here will always be the smallest element in their given period. Okay? So the smallest element in period 2 is a noble gas. The smallest element in period 5 is a noble gas. The smallest element in existence is helium, which is a noble gas. So there's no element smaller than helium. Okay. The valence electrons trends is trend number 3. This one's pretty straightforward. How do we know how many valence electrons something has? You got it. The group number is equal to the number of valence electrons. If you're in group 6, you have how many valence electrons? 6. There you go. If I pick any random element, so I'm like, oh, whatever this element is, I don't even know what that is. It's in group 2, so it must have 2 valence electrons. Okay, pretty straightforward. What is the one exception to this rule? Helium, that's right. Helium is a noble gas, and it has how many valence electrons now? 2. How many valence electrons do most noble gases have? 8. Nice. Most noble gases, since they're in group 8, have 8 valence electrons. Helium, right here in the top right-hand corner, is the one exception. It has 2 valence electrons. That's the only exception to that rule. Valence electrons is a very straightforward rule. Nothing too kooky. I will always ask you how many valence electrons helium has, so don't get caught sleeping on helium. That's a free half point on any quiz or test this unit, because I'm going to ask you how many valence electrons helium has every time. And the last trend is reactivity. This is definitely the trickiest trend. I think part of the reason why it's tricky is because people mix it up with atomic radius a lot. Okay, so they'll like think atomic radius or size are the same thing as reactivity, and they'll get a little goofed up. So non-metals, so like the halogens, they get more reactive as the element gets smaller. Okay, the most reactive non-metal is fluorine for two reasons. One, it's a halogen. Halogens are a very reactive family, or group, you can say family or group. And number two, it's the smallest non-metal in the halogens. So fluorine is the most reactive non-metal. Metals are the exact opposite. They get more reactive as they get bigger. So as you go down a group, you have the most reactive metals. Because the alkali metals are the most reactive group, and because francium is the bottom of that most reactive metal group, francium is going to be the most reactive metal. So one way I try to encourage people to remember that, F, fluorine, most reactive non-metal. Fr, francium, most reactive metal. So if you remember F and Fr sort of at different opposite corners of the periodic table as the most reactive for the metal and non-metal respectively, that can maybe help a little bit. That's the trickiest trend for sure, okay? So that's the one where I spend the most time studying if there's trends that you still need a little polishing on, okay? Are there any questions currently? That was a lot. Are there any questions currently? Feeling okay about that? Okay. Now, this right here is a question from last week's quiz. This is the second most missed question on the quiz. Some of you guys got this right already. That's okay. But I want to go over this question. And here's why. So I'm going to go over the three most missed questions from last week. At the end of this period, when you guys do your lecture questions, you'll be asked the exact same three questions at the end of this period with different elements. So at the end of this period, so about 15 minutes from now, Bree's going to open up for a little lecture question. She's going to have a question where it's like, rank these elements from smallest to largest. It's going to be this exact same picture. Only difference, 4 different elements. Does that make sense? Okay. So this first one, we have calcium, chlorine, bromine, and strontium. They're all over the periodic table. So you're like, okay, I don't really know how to compare all of these. How do I know for sure which one's bigger than the others? What I suggest you do is, I suggest you find the two that are in the same group at least, start there, and sort of reason your way through the rest. Okay? So chlorine and bromine, elements 17 and 35, are in the same family. They are both halogens. Okay? So they're sort of towards the right-hand side of the periodic table if you want to find those, elements 17 and 35. So let's compare these two. Bromine is right below chlorine, which means it has one more what? Energy level. Nice. So bromine has one more energy level, and therefore bromine is what compared to chlorine? Bigger. You got it. So here's chlorine. I know for sure it must be smaller than bromine. I don't know about the rest yet, but I know this is definitely true at this point. Okay? And notice how, since it's going from smallest to largest, I'm going to write my smallest one on the left and my larger one on the right. Just make sure my notes don't confuse me. All right, so now I'm going to throw calcium into the mix. I'm not really sure where it lands yet. Calcium, element number 20. Okay, it's in the same row as bromine, so that means it has the same number of what? Energy levels, right? So that doesn't really help us in terms of size. So calcium and bromine have the same number of energy levels. However, bromine has a lot more positively charged protons in its nucleus. So it does what to those electrons on the outside? Pulls them tighter, right? So bromine's actually smaller than calcium. So we know for a fact bromine is smaller than calcium. So if here's calcium, it's bigger than bromine, which is definitely bigger than chlorine. So actually we know 3 of the order right now. Okay? So do you guys see how even though you didn't compare chlorine and calcium directly, you know for a fact calcium has to be bigger than chlorine. Does that make sense? Okay. Last one we got to figure out is strontium. That's element number 38. It's right below calcium. So strontium is right below calcium, so therefore it has one more energy level, and therefore it is what compared to calcium? Bigger, right? So strontium is definitely bigger. Like, okay, well, strontium is definitely bigger than calcium, and calcium is definitely bigger than bromine, and bromine is definitely bigger than chlorine. Well, there you go. There's my order right there. Okay, so I start plugging them in, chlorine, bromine, so on and so forth. Okay? And you'll notice, generally speaking, the closer you get to helium, the tiniest element in existence, the smaller elements will be. All right. Now, again, you'll have this exact same question, but it'll be 4 different elements at the end of the period. The second most this was the most missed question on the quiz from Friday. Reactivity, okay? First thing, please make sure you're paying attention. This is about reactivity, not size anymore. So make sure you read your question carefully, because sometimes an element is smaller than another, but it's more reactive. So you don't want to confuse those two trends. So again, I don't really know exactly where to start. There's a lot of strategies. I'm just going to pick 2 elements that are in the same group again, so I can compare those directly. Fluorine and chlorine, elements number 9 and 17, are both halogens. What do we know about halogens? They're very what? Reactive. Okay, so these 2 are very reactive. Which one has to be more reactive than the other, though? Fluorine, right? It's smaller than chlorine, so fluorine is the most reactive in the halogen family. So we know this so far. We know for sure fluorine is more reactive than chlorine. Let's just keep working our way through. Argon, what is argon? Okay, what do we know about noble gases? It's not reactive at all. So I don't know exactly how reactive chlorine and fluorine are, but I know that they're not 0, right? Whereas argon is like 0. So argon's definitely got to be all the way over here somewhere. I don't know if phosphorus belongs in between these guys, here or here or here yet, but I know that argon's definitely going to be the least reactive because it's a noble gas. All right, phosphorus. Element 15. Is it in any special family or group? No. So we don't know if it's super reactive or not reactive. It's not a noble gas, so we know it must be sort of reactive. But at the same time, it's not a halogen, so it's not super reactive. In other words, it's kind of reactive. So it means it must be more than argon, because it's not a noble gas. But it's also not going to be as reactive as a halogen, so it's got to be less than chlorine. And so there's our order. Yes, ma'am?
So say we had like francium and fluorine, which one would be more reactive?
Oh, that's a great question. She's asking, okay, what about, how would you compare the most reactive alkali metal versus the most reactive halogen? The answer is, I'm not going to ask you to do that. I'll only ask you ones where you can reason your way through them. Yeah, I'm not going to ask you to compare 2 incredibly reactive ones. They're not in the same family. Does that make sense?
Which one would be more reactive?
You know, I got to think about that one. I don't know off the top of my head which one's more reactive. I know that a gram of francium could blow up a pretty large area. As remember, guys, that alkali metals demo where potassium, like, you know, it was like boom, and that was like maybe a half a gram of potassium. That was like almost no potassium. And potassium is like 3 above francium. Anyways, great question, but you don't have to worry about that. Yes, sir.
So how do you, I think you mentioned it, but how do you store those like really reactive?
Oh, well, francium, the government would never let me get my hands on, but like potassium and sodium, we store them in mineral oil, so that way they can't actually even interact with the moisture in the air, because that could cause problems. Yep. Yep.
So where are they?
They're in a locked cabinet, behind a locked door, behind a locked door, behind a locked door.
Okay, good to know.
Yep. So you got to unlock 4 things to get to them. Because they're, you know, really dangerous.
I mean, look at me, like.
Space like, whoa, yeah, what's going on?
Look, how do we go break through and get?
Oh, you know, it's all fun and games. All right, anyways. Any questions with this? This is probably the toughest question, in my opinion, on the quiz. All right. Let's go through one more real quick, and then I'll let you guys kind of study on your own before you take that 3-question quiz, all right? Configuration of copper. This was top 3 most missed questions from last week's quiz. I'm going to go ahead and just walk through how I would do this. What I strongly suggest when I'm asking you guys for a full configuration, I would bust out a scrap sheet of paper, pencil, I would write the thing itself, and then compare what I get to the multiple choice that I have on my handout. Does that make sense? So if I'm looking at a periodic table, this is copper right here. I know that my table right here isn't labeled, but that's where copper is. Element 29, towards the end of that first row, the transition metals. Okay, this is my S block. This is my D block. This is my P block. Okay? So I'm just going to go ahead and write through this. Hey, so this first row, that's called what? Yep. And what number S? S what? 1S, right? I'm going to go right through it because I'm going all the way down here. So it's 1S2. I should make that S maybe a teeny bit smaller. Uh-oh. Uh-oh. Oh my goodness. I'm falling apart. You guys, I'm falling apart. 1, S2. Okay, so I finish that row, and then I get to here. What's this called? 2S, right? I'm going to finish that. 2S2. Takes me to here. That's 2P, right? Second period, P block. There are 6 in the P block, so 2P6. Once I finish that, now I'm down here, which is 3S. Then I get to 3P6. And this should be a review, so I'm going a little fast. This might be something you want to spend more time on your own. After I finish 3P6, which is right here, I get to 4S2. And then finally, I'm in the D block. Now, what's special about the D block? It's always what?
1 behind.
1 behind, right? So this is not, even though it's in the 4th period and we just hit 4S. This is 3D. And now we need it. Meg, do you have a question there?
Oh, no, sorry.
It's okay. We're at 3D, and then we just have to count how many in we are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3D9. Okay? So then I have that written out. 4S2, 3D9. I compare that to the options I'm given. So this one, 4S2, 4D9. Okay, you'll always see me throw one of those wrong answers in there. That's definitely not it because it's not 4D9. So that's gone. 4P9. Well, first of all, 4S doesn't go to 4P. There's the transition metals in between there. And P can only hold 6, right? So that also doesn't really make any sense. So there's a problem there. 4S11. This is the person who was like 4S1, 4S2, and instead of switching over to 3D, they stuck in the 4S. 4S1, 4S2, 4S, blah, blah. S can only go up to 2, so that's just sort of catch your attention. Now let's make sure this last one is in fact correct. 4S, and we go to 3D, right? And it takes us to 3D9. That is why that's winner, winner, chicken dinner. Any questions for me? Yes, sir.
If you just look at the short configuration, like the last one, and then just figure out if it's the right one.
Quite frankly, on this, where I have the choices ahead of me, I really just focus on the end, yep. But, you might get to the end in 3D9, so then you have to kind of work your way backwards.
And see if it's messed up.
Mm-hmm. And on your Unit 5 test this Friday, you're going to have to provide the full configuration from beginning to end. Does that make sense? So make sure you still can do that. Any other questions? Okay, here's what I want from you. You guys have the periodic table reasoning puzzle, so this is in your packet. I want you to go ahead and look at reasoning puzzle number 3. I encourage you guys to try number 2 last week. You didn't really have much time to do puzzle number 2 last week, so if you have a blank periodic reasoning table number 2, that's okay. You probably were working on something else, not a big deal. Take a look at number 3. I'm just going to remind you guys how we do this. So the very first clue tells us the groups of all these unknown elements. Okay, so like elements E, C, and F will be in the same column. They're in the same group. We don't know the order or which column, but we know they're together. And please remember, this is group 1, this is group 2, so this is like hydrogen right here. This would be beryllium. These are the transition metals which are not part of this puzzle. And you guys see where boron is, element number 5? That's what this box is right here, the top of group 3, right? Anyways, so let's look at the first clue. It says A has a valence electron configuration that ends in P1. Okay, well this is our P block right here. That's our P block. This first column is P1, right? So P1 would be this first column, so that means A and all the other members of its group. So A is with Z, N, and A. So that means that Z, N, and A go in this column right here. We don't know what order, but we know those are the 3 elements that belong in these 3 spots. Does that kind of make sense? Okay. So this is not for a grade. This is just good practice because it helps you think about the parts of the periodic table as well as the trends. The answer key to this is in your Tuesday folder on Schoology. I strongly suggest that you guys try this without the enter key and then kind of check afterwards. So why don't you guys go ahead and get cooking on this. You also have a crossword puzzle you guys can do after that if you guys get done with that. In person, folks, I'm going to check in with my remote people, let them go, and I'm going to come check in with each one of you individually. Are there any questions before I do that? Yes, ma'am.
I don't get how you got Z and A. Like, I know that's up at the top, but like.
So this is saying that A, N, and Z are all in the same group. They're all in the same column somewhere. And we just learned that A has a configuration that ends in P1.
Oh.
Yeah, so if A is in this column, that means Z and N also have to be in that column. Does that make sense?
Yeah.
Yep, good question. All right, well, the playlist has like 70...